Dive under the surface off the Palos Verdes Peninsula on a clear afternoon, and you'll see something that wasn't supposed to be possible. Towering blades of giant kelp rising from the seafloor toward the light, schools of fish threading through the fronds, harbor seals banking through corridors of green. For anyone who knew this coastline a decade ago, who remembers when the kelp was gone, it feels like a miracle. But here's the thing about miracles. They rarely arrive the way you planned them. The kelp forests are coming back along parts of the California coast. That part is real, and it's extraordinary. By 2024, a 70-acre forest off Palos Verdes had become the biggest kelp restoration success story in the United States. The nonprofit Bay Foundation eliminated some 6 million urchins over the past decade, restoring close to 80 acres of kelp forest in Southern California. Scientists, divers, fishermen, and volunteers poured years of exhausting, cold, physically brutal work into this outcome. And it worked, at least partly. But what came back is not what was there before. The species returned in the wrong order. The predator-prey relationships don't match any prior model. And some of the behavior scientists are watching through their dive cameras have no clean explanation. The recovery of California's kelp forests has turned out to be just as mysterious, just as humbling, and just as full of surprises as the collapse that preceded it. And that might be the most important lesson the ocean has ever tried to teach us. To understand what's strange about the comeback, you first have to understand how catastrophic the crash was. From 2013 to 2017, a mass of unusually warm water nicknamed the Blob hugged California's coast. The timing was devastating. A perfect storm of warming temperatures, sea star wasting disease, and purple urchin explosions. That disease killed an estimated 6 billion sunflower sea stars, nearly 95% of the global population. The sunflower sea star was the linchpin nobody fully appreciated until it was gone. The largest sea star in the world, spanning more than 3 feet, sporting up to 24 arms, it was a dominant predator on California's rocky reefs, keeping purple urchin populations in check and kelp forests healthy. When the sunflower sea star collapsed, the urchins had no natural check, and urchins, when they run out of food, don't just die. They enter a years-long dormant state, lower metabolism, shrunken gonads, reproductive shutdown, and can survive an additional 20 to 40 years, reawakening to feed on any new kelp. That is the cruel trick of a barren. It is self-locking. The urchins that created it can hold it open long after the kelp is gone. On California's north coast, more than 95% of the offshore kelp canopy in Sonoma and Mendocino counties was lost since 2013. The sea floor looked like the surface of the moon, gray, barren, motionless, except for the slow sweep of spiny, purple creatures covering every inch of rock. Red abalone starved. Fish departed for deeper water. Now here's where it gets genuinely strange. When restoration teams began clearing urchins and kelp started returning, they expected the ecosystem to reassemble itself in something like reverse order. Remove the pressure, and the system climbs back up the same ladder it fell down. But that's not what happened. In some areas, the canopy returned before the fish communities that were supposed to support it. In others, the predators arrived first, but not the predators anyone expected. California sheephead are now appearing in greater numbers along the central coast, stepping into an urchin predator role that the sunflower sea star used to fill, in places where sheephead weren't historically common. The food web isn't recovering, it's improvising. Off Palos Verdes, the results have been stunning on the surface but puzzling underneath. Fish biomass across the reef complex is up 166%, adding nearly 4 metric tons of living fish to the ecosystem. That sounds like a triumph, and in many ways it is. But which fish came back, and when and why they behaved as they did? That's where the science gets uncomfortable. Animals moved in before the classic food web was in place. Some species showed up in numbers that surprised even the researchers monitoring them. Others that should have returned by any ecological model were conspicuously absent. Here's a question worth sitting with. If you were a marine biologist watching this unfold through a dive mask, would you call it a recovery, or would you call it a new ecosystem forming in the same location as an old one? Comment your answer below, because that distinction is at the core of what scientists are now arguing about, and it changes everything about how we manage these waters going forward. The unexpected rebound complicated a theory scientists had applied to California's kelp collapse, alternative stable states. The theory predicted the urchin barren was stable, that it would resist recovery. And in the north, it still largely does. But in places where conditions shifted, where currents cooled, where urchin-eating predators filled the gap, the kelp came roaring back in ways the theory didn't fully anticipate. Meanwhile, the creature that should be at the center of any real recovery is still almost entirely absent. Sea star wasting disease wiped out over 90% of the sunflower sea star population. Only a handful have been seen in the wild since. Without them, the food web reassembling itself is structurally different from the one that existed before. There is hope. In August 2025, researchers published a peer-reviewed study in Nature Ecology and Evolution identifying Vibrio pectinatida, a saltwater-loving bacterium, as the likely dominant pathogen behind sea star wasting disease. After more than a decade of searching, scientists finally know what killed the stars. In December 2025, juvenile sunflower stars reared in human care were successfully placed into the ocean and later retrieved as part of a pioneering field study. The California Ocean Protection Council approved over $500,000 to advance reintroduction through a partnership with the Nature Conservancy, the California Academy of Sciences, and the California Department of Fish and Wildlife. But even if those reintroductions succeed, nobody knows what happens next, because the ecosystem those sunflower stars would return to is not the one they left. The urchin populations are different. The fish communities are different. The water is warmer. The sheephead, the lobsters, the sea otters along the central coast, they've already been running this system for years. Dropping a keystone predator back into an ecosystem that has reorganized itself around its absence is not like pressing rewind. It's more like introducing a new variable into an equation that's already been solved differently. The North and the South now tell completely different stories. The same coastline, the same species, but two radically diverging trajectories. And scientists are still trying to understand why the recovery looks so different depending on where you drop into the water. Even the kelp itself, when it comes back through human intervention, may be coming back weaker. Breeding kelp in captivity without careful attention to genetic diversity risks producing outplanted forests less able to cope with the next marine heat wave. The ecosystem is not recovering on its own terms. It's recovering on the ocean's new terms, and the ocean has changed. California's canopy-forming kelps often called the sequoias of the sea, can tower over 100 feet in height and support everything from microscopic plankton to gray whales. That is what's at stake. Not just a pretty underwater landscape, a system that underpins fisheries, coastlines, carbon cycling, and the livelihoods of communities up and down the coast. What this recovery has revealed, above all else, is that ecosystems are not machines with parts you can simply replace. They are webs of relationships between species, between behaviors, between histories that stretch back far longer than any scientific study. When you lose a keystone species, you lose every interaction it was having, every behavior it was suppressing, every species it was feeding. When the forest comes back, it comes back without the memory of all that. It has to negotiate a new set of rules from scratch. The scientists watching this unfold are not defeated by that complexity. Every behavior that doesn't match the model, every species that shows up in the wrong place at the wrong time, that's data. That's the ocean telling us something we didn't know before. The kelp forests are back, parts of them, in some places, for now. And they are strange and beautiful and full of questions. Nature's comeback doesn't owe us a familiar ending. It just keeps going, writing new chapters in a language we're still learning to read. If this story has you thinking differently about how ecosystems recover or collapse, hit subscribe so you don't miss what we cover next. There's a lot more ocean out there, and almost none of it is behaving the way anyone expected.